This video is on Unit 10, Lessons 12 and 13. And today in Lesson 12, we are going back to working with fractions, but this time we are actually going to be solving with fractions because there is going to be an equal sign in the question, which means you actually have to solve for x. In the past, we were just adding and subtracting with rational fractions. So therefore, we didn't really get like an answer, like a number for x, because we weren't solving for anything. We were just like combining fractions together into one fraction by either adding or subtracting. Well, today we're actually going to be solving. So the key word is solving. So we are solving equations, which means you are going to find what x equals, or whatever variable they're working with. Okay, so it is very similar to what we've been doing, where when you have fractions, you need to get common denominators. So the first thing you're going to do is find the least common denominator and make sure each fraction has that denominator. And you need to check every single fraction, even the ones on the other side of the equal sign. So if you look at all three of them, you could turn them all into 4x. These guys already are 4x. This guy is not. So if I multiply him by 2x, top and bottom, I'm going to rewrite what I now have. I now have 2x over 4x minus 9 over 4x equals 3 over 4x. Now, it's very tempting to reduce this 2x over 4x, but if you reduce it, then you won't be able to combine them together into one fraction because they won't have common denominators. So now I can rewrite this as 2x minus 9 all over 4x equals 3 over 4x. Now you'll notice the bottoms are the same on both sides of the equal sign. Well, think for a minute what you're actually trying to do when things are set equal. When you have two things set equal to each other, you are saying they are identical. They are the same. Well, the bottoms already are the same. So no matter what you plugged in for x, you could plug in 100 for x. The bottoms will both be 400. You could plug in 2 for x. The bottoms would both be 2. So no matter what value you plug in for x, the bottoms will be the same. But the tops are not the same. So that's where you actually have to set up an equation for the tops and solve for x. If that doesn't make sense to you, you could simply cross multiply. Remember, when you have two fractions set equal to each other, you cross multiply to solve for to get rid of the fractions and then solve. Well, watch what happens when you cross multiply. If you were to cross multiply, you would multiply this 4x up to the top. So I'm not even going to actually multiply it out. I'm just going to show you. You would get 4x times 2x minus 9 equals 3 times 4x. Well, when you start to get x alone, if you divide this 4x, it doesn't even matter which 4x you divide over. But as soon as you divide both sides by 4x, they go away anyways. And you'll notice you're left with just the tops equal to each other. So if you want to actually cross multiply it out, if that doesn't really make sense to you, the whole get the bottoms the same and then set the tops equal, but this will save you a ton of time. If you can just know that once the bottoms, you have one fraction on the left, one fraction on the right, and the bottoms are the same, then you just set the tops equal and solve. So now you're going to add 9 to the other side. 2x equals 12. Divide by 2, x is 6. Now, the problem is you need to check. If you want to like make this a bigger star so you remember to do this, you need to check, because with fractions, if your value of x, it's usually when you get two answers for x that you definitely need to check them, because one of them or both of them may not work. If you plug in your value for x and you end up getting 0 on the bottom, that means that is not an answer, because you cannot have 0 on the bottom of a fraction. So let's try the next one. The next one is a little bit not as nice, because look at these denominators. The first thing I'm going to do is put parentheses around anything that has a plus or minus, just so I remember that I can't cancel those out unless I can cancel out the whole parentheses. Then I should always be thinking I need to factor. So I'm going to factor this guy. He factors to be x plus 5 times x plus 3. Well, that's good news, because now when I go to get my common denominators, it's going to be x plus 5 times x plus 3. Remember, your denominator needs to have like one of everything that all of the fractions have. So because this guy has two things, that means the rest of them need those same two things. Well, he already has an x plus 5, so he only needs x plus 3. And then the other side, the right side, already has the x plus 3, so he needs the x plus 5. Now the denominators are all the same. They are all x plus 3 times x plus 5. So now that they're all the same, I really only have to worry about solving the top. So when I multiply out this top left, I get x squared plus 3x plus 1x, that's 4x, plus 3, plus 18 equals, and if I multiply the 9 by x plus 5, that's 9x plus 45. Now, as soon as you see that there's an x squared, you should be thinking to yourself, I'm going to have to factor. Before you factor, though, you have to get it equal to 0. I also should probably combine my like terms here. 18 plus 3 is 21. So now I'm going to minus the 9x over to the other side, minus the 45 over. So minus 9x minus 45. So I get x squared. 4 minus 9 is negative 5x, and you have 21 minus 45, which is negative 24, equals 0. Now you're going to factor this using your 1 AM. The multiples of 24 that are negative 24 that add up to negative 5, so that would be negative 8 and positive 3. And then whenever you're trying to solve, because it says what equals 0, what values of x will give you 0, that's when you t-chart and you get x equals positive 8 and x equals negative 3. And before you go getting all excited that you just got your two answers, you need to double check that when you plug those in, you don't get 0 on the bottom. I could care less what I get on the top, but if I get 0 on the bottom of a fraction, that's a big no-no, so you can't do that. Well, if you plug in negative 3 on the bottom, so even if I just check it in the one fraction, so, well, let's check this side. So that was 9x plus 45 all over x plus 3 times x plus 5. And actually, you don't even have to check that version. You could have checked the original, because even if you just check it in the original, negative 3 plus 3 is 0, so you are going to get 0 on the bottom if you plug in negative 3. So therefore, negative 3 does not work. So cross off negative 3, your only answer is 8. If you plug in 8 on the bottoms, you won't get any zeros. So there's only technically one answer. Okay, and that's it for that lesson. On to the next one, which is almost the same thing, except for it's with inequalities again. So to solve with an inequality, the first thing you want to make sure, if you want to write down some steps, you want to get 0 on one side. Now, in the first two examples, they already have 0 on one side. So therefore, you don't even have to do step 1. Step 2, you need to, if necessary, make sure you only have one fraction. So get 0 on one side, get one fraction on the other, which means you might have to get common denominators to add them together or subtract. Get one fraction on other side. Step 3, you're going to find the values of x that give you 0. Find numbers for x that give you 0. Step 4, you're going to find any values that make it undefined. Find numbers that make the fraction undefined. And then you're going to sign pattern picture. And I will review how to do that. That was back a couple units ago. Sign pattern picture. Okay, so step 1 is already done for the first example. 0's on one side, one fraction on the other. Step 2, find what numbers would actually give you 0. So you're really only going to worry about the top, because if you can get 0 on the top, put that in parentheses, on top. If 0 is on the top, 0 divided by anything is 0. So I'm going to do this. X minus 5, I'm going to set the top equal to 0. I would add 5 over. So x equals 5 makes that fraction 0. The next step, find any numbers that make the fraction undefined. That is when 0 is on the bottom. So I'm going to set the bottom equal to 0. And it turns out x equals -3 makes the bottom undefined. So now you're going to sign pattern picture with those two numbers. Sometimes it's going to be more than 2 numbers. It might actually be 3 numbers if you have 2 zeros. It depends on if the top is a quadratic or not. So I'm going to put, I cannot ever be equal to -3, because that gives me a 0 on the bottom. But 5, I can be equal to 0 because of this right here. And 5 is what made the fraction 0. So I'm actually going to fill in that circle. Now you're going to pick a number. Remember I told you to try to pick 0 if it's, as long as it's in between your two numbers. And 0 is. You're going to pick a 0, plug it in, and see if you get a positive or negative number. Well, 0 minus 5 over 0 plus 3, that equals -5/3, which is a negative number. So therefore, I'm going to put little negative signs where 0 is, and 0 is in between. Now I have to pick a number on the other side of 5. I'll pick 6. So 6 minus 5 over 6 plus 3, well, 6 minus 5 is 1 over 9. That's a positive number. So I'm going to put little plus signs, and then pick a number on the other side of -3. So let's pick -4. -4 minus 5 over -4 plus 3. That's -9 over -1. That reduces to a positive 9. So that's a positive number. So I'm going to put little plus signs. Well, now I have to ask myself, well, did I want to be bigger than or equal to 0, which means positive, or less than or equal to 0, which means negative? Well, I want it to be bigger than or equal to 0, so I'm going to pick, my answer is going to be all the x's that have plus signs. So I'm going to write down, it depends on how they want your answer. Let's do our answer in interval notation. So I want to go from -infinity up to -3, but I cannot include -3 or -infinity. Union with, then I want to pick back up at 5, but I can include 5, and then I'm going to go on to infinity. Those are all the x's that would work in this equation. I would get a number that's bigger than or equal to 0. You should check your answer and make sure that that is in fact true. Plug in 7, plug in 8, make sure you get a number bigger than or equal to 0. Plug in -5, make sure you get a number bigger than or equal to 0. Okay, the next one. This time, we don't have to do steps 1 and 2 again, but the top and bottom are a little bit more complex. The tops, you have to find where do you get 0. That's where you set the top equal to 0. You can just remember in your head that you are setting both the top and the bottom equal to 0 and solving, and those are your special numbers that you use for your sign pattern picture. So up on top, if you factor this, that would be x plus 4, x minus 1. So your two x's that give you 0 are -4 and +1. Then you have to find any x's that make the bottom 0, which they definitely don't work because it's going to be undefined. So this factors to be x minus 3 times x minus 3. Well, the good news is that's technically only one number because you get the same number twice. You get x equals 3 and x equals 3. So your 3 numbers this time, you could have had up to 4, but those were the same. You're going to have a dash at -4, at 1, and at 3. Now, the one that it can never be equal to is definitely 3, because that's what makes the bottom undefined. But you'll notice in this particular equation, I can't be equal to 0 either. So therefore, they're all open circles this time. Now you just have to check. I want to be less than 0. So I ultimately want the intervals that give me negative numbers. So you're going to have to plug in numbers in between all of these and see if you get a positive or negative. So first I'm going to pick 0. 0 is in between -4 and 1. So if you plug in 0, that's -4 over positive 9, which is a negative number. So I'm going to put negative signs in between here. So that's definitely one of my answers. I just have to find if there's other intervals that also give me negatives. So now the only number between 1 and 3 is 2. So if you plug in 2, you get 2 squared, which is 4, plus 3 times 2 is 6 minus 4. That's 10 minus 4, that's 6. All over, I plugged in 2, so that's 4 minus 12 plus 9. Well, 4 minus 12 is -8, plus 9 is 1, so 6 over, that's a positive number. Now let's plug in 4, because that's bigger than 3. Smaller the better. So 4 squared is 16, plus 12 minus 4, all over 16 minus 24 plus 9. So 16 plus 12 is 28, minus 4 is 24, so that's positive. Divided by, well, 16 minus 24, that would be -8, plus 9 is a positive, so that's also positive. And then the last one, we got to check -5. Be careful with negatives. When you are squaring negatives, remember they're actually positive. So -5 squared is actually 25. 3 times -5 is -15 minus 4. 25 minus 15 is 10, minus 4 is 6. All over, -5 squared again is 25. A -6 times a -5 is actually positive 30. And then plus 9, that's a positive number, so these are positives as well. So your only spot where you are negative is from -4 to 1, and you can't include either one of those. Okay, and then the last example is a little trickier because you are going to have to follow steps 1 and step 2 first. Step 1 says make sure that 0 is on one side, which it's not, and then it says make sure you have one fraction on the other. Well, as soon as we go to get 0 on the right side, so I'm going to subtract the 5 over to the other side. I'm now going to have x over x minus 8 minus 5 over 1. I don't really need the over 1, but just to show you that I now have 2 fractions on the left side. So I need to get one fraction. So again, the x minus 8 is one quantity, so I'm going to put parentheses around it. But this guy also needs an x minus 8 to have common denominators so that I can combine them into one fraction. So the first thing I like to do, though, actually before I wrote that, I should have changed this to addition and given the minus or the negative sign, changed the signs of anything behind it on top. Now when I multiply through, I'm actually going to distribute a -5 into the x minus 8. So I now have x plus a -5x plus a 40, and it's all over x minus 8 because they both had x minus 8 as their denominators. And now when I combine my like terms, I get x minus 5x is -4x plus 40 all over x minus 8. So now on to the next step. We have to find out which x's give me the number 0. Remember that is, so basically what number can I plug in on top to get 0? So I'm going to set the top equal to 0 and solve for x. Well, if you add the 4x over to the other side and then divide by 4, you get x equals 10. So that is the number that gives me 0. So that's one of my numbers I'm going to use in my sign pattern picture. Next, I have to see if there's any numbers that would wouldn't work, that would make that fraction undefined, and that's when 0 is on the bottom. So you set the bottom equal to 0 as well. You end up getting x equals 8. So 8 does not work. So when you do your sign pattern picture chart, you can definitely put an open circle around 8 because that will give you an undefined answer. Whether or not 10 is open or closed, we have to look and see if we can be equal to 0. We can because of the equals to, so that's going to be a filled in circle. Now you need to check, and you're going to check using this equation, the one that is less than or equal to 0. So you're going to check into that one. And let's first check 9, because that's the only number between 8 and 10. So if I plug in 9, I get negative 4 times 9 plus 40 all over 9 minus 8. Well, that's negative 36 plus 40 is 4 over 1. That's a positive number, so I'm going to put positive signs in between where 9 was. Now I have to check on either side, so let's check 11. So we're going to have negative 4 times 11 plus 40 all over 11 minus 8. Well, that's negative 44 plus 4, that's negative 4 over a positive 3. That's a negative number. So negatives go where 11 was, which was on that side. And then let's check below on the other side of 8. So let's check 7. So that's negative 4 times 7 plus 40 all over 7 minus 8. So that would be negative 28 plus 40. So that is 12 over negative 1. That's a negative number. So these are also negatives. Now I have to ask myself, well, did I want the numbers that are less than 0, which are negative or equal to, or greater than or equal to 0? Well, I wanted them to be smaller than or equal to 0. So I want the negatives. I want to know, where do I get negative answers? So in interval notation, whoopsies, we can't ever be equal to infinity. I yell at you guys all the time for that. So it needs to go from negative infinity up to 8, and we cannot ever be equal to 8. After I go past 8, I get positive outputs for a little while. I don't want those, because I want to know, where am I smaller than or equal to 0. And then at 10, I can be equal to 10, because it said I can be equal to 0, and 10 will give me the number 0. Up until infinity, as I move past 10, I will always get a negative output, which is what I wanted. I wanted to be smaller than or equal to 0. And that is it for this video.